Okay, this is a demo class on the topic continuity. As you can see, whatever is being displayed on the screen, where I'm moving the mouse pointer, you can see on the screen a black dot. That is the tip of my pen when I'm writing on the screen. This is how the screen will be displayed to you when you are doing the online class through Google Meet. You will be able to hear me, my audio, and the video is what I write on the screen is that video you will get to see. On your end, as a student, you should have a tab or a laptop or a mobile phone with a broadband or a Wi-Fi connection so that there is no interruption in the network. You will keep your mic unmute. You will keep your mic unmute only when you are asked to do so, or when you are asked a question and you need to answer that question, or else your mic should be always in a mute position. When I ask you anything, then you will unmute and say the answer. Okay, the topic is continuity. Now, what is a continuity? Continuity means, suppose this is a function, this is an axis, x-axis and y-axis. Any function is plotted on the, like this it is plotted. This is y is equal to fx. It is the plot of a function. Now, if you are asking that whether this function is continuous or not at a point, at any point, say, let's say that point is this is that point, x is equal to a. You want to know whether at the point x equal to a the function is continuous or not, then what we will do, we will look for the value of the function at the left of the point and at the right of the point. That means you're standing at that point x equal to a and you're trying to look towards your left and you're trying to look towards your right. If towards your left and towards your right the value of the function at that point is same, is equal, that means the function is continuous, or else it is not continuous. So how to look to a function's point to a left? We will do a minus h. We will look to a function that is f of a minus h. A minus h is the distance we are going towards the left. Also, we will try to check the function's value at f of a plus h. Plus h is the value that we are going towards the right from the point a. And what is a? A is the point where we need to check the function's continuity. That is the point where we need to check the function's continuity. So what I will do, f of a minus h and f of a plus h. And what is this h? H is a very small quantity, so this h limit will be 10 to 0. This h limit will be 10 to 0. So if the left hand limit is equal to the right hand limit is equal to the function value of the function at that point, that means the function is continuous. If the left hand limit, the right hand limit and the value of the function at that point is equal, that means the function is continuous. This is how we prove it. Now let us see with the help of an example. I hope that for the maths you are following R.S. Agarwal. One book is there, R.S. Agarwal, or you can follow R.D. Sharma. These two books are a very good book for a practice in mathematics. Apart from this, if you are a student of class 12 appearing for your board exams, then before the board exams, I recommend that you practice the Oswald question papers, question bank, Oswald question bank. One book is there available in the market. You can purchase the book Oswald question bank and start practicing the PYQ questions from every chapter. 1 marks, 2 marks, 3 marks, 4 marks, 5 marks, all these various kinds of questions are given in this book. You can practice. Apart from this, there is NCERT book, that is also important, but I recommend that you practice the questions from R.S. Agarwal, especially the examples of R.S. Agarwal and the Oswald PYQ questions you practice. It will be more than sufficient to score a very good marks in your CBSE if you do it dedicatedly. NCERT is also good, but NCERT has got less number of questions, but for mathematics you need ample amount of practice, which is why I recommend R.S. Agarwal along with Oswald and the PYQ questions of the CBSE. Now see, suppose we are solving one question. Based on this continuity, let us solve one question, then you will be more clear about the topic. The question I am writing on the screen, you can see that fx is equal to x cube is a function and is to be shown to show that fx is continuous at x equal to 2. This we need to show. Then what we will do? First we will find the value of the function at the point 2. So we will write here f of 2 is equal to 2 cube is equal to 8. Then we will find the left hand limit. So left hand limit is equal to limit x tends to limit x tends to h minus f of x, limit x tends to 2 minus, because we need to check the continuity at the point 2. So I will write here x tends to 2 minus f of x, which is equal to limit h tends to 0 f of 2 minus h. That h is a very small quantity, 2 minus h. Now what is this 2 minus h? 2 minus h, if you put in the function, it will be equal to 2 minus h whole cube. 2 minus h whole cube, where this limit h is going to 0. So if I expand this one by the a minus b whole cube formula, it is 8 plus h cube, 8 minus h cube, 8 minus h cube minus 12h plus 6h square. Since h is going to 0, so this term and this term and this term is all going to 0. All this is 0. So it is coming equal to 8. That is the left hand limit. Now the right hand limit. Limit x tends to 2 plus f of x is equal to limit h tends to 0 f of 2 plus h is equal to limit h tends to 0 2 plus h whole cube, that is equal to 8 plus h cube plus 12h plus 6h square. This terms with the h will go to 0, so it is 0 and the remaining is 8. So we can see that the left hand limit and right hand limit, they both are same, they are both are equal. So I will write here therefore limit x tends to 2 minus x tends to 2 minus f of x is equal to limit x tends to 2 plus f of x is equal to limit x tends to 2 fx. Left hand limit equal to right hand limit equal to the function's value, that is equal to f of 2, that is equal to 8. That means fx is continuous. Therefore fx is continuous at x equal to 2. Hence proved. This question was a very easy question and a very basic question. In exam in CBSE, you won't get this kind of easy questions. You will get a questions with a bit more difficulty, which is having bit more difficulty. Let us see in exam what kind of questions are coming. One question I am showing you what exactly the CBSE tries to give in the exam. This is a PYQ question that I am going to discuss right now. Please look into the screen. The topic is, the question is fx is equal to, this kind of functions is called piecewise continuous functions. It is a discrete functions because it is made up of several functions, several other smaller functions are together combined into one single function. So it is a stepwise continuous function. Now say it is 1 minus cos 4x by x square if x is less than 0. Value is a if x is equal to 0 and the value is root x by root 16 plus root x minus 4. This entire inside the root x by root of 16 plus root x, which entirely is inside the root, minus 4 is entirely outside the root, and this is given if x is greater than 0. Now this kind of functions, it is called a step function. You can see 3 different functions are together combined to make a single function. So you have to show that in this function, you have to show that if the question is if fx is continuous. Already the question is saying that the function is continuous. If fx is continuous at x equal to 0, find the value of it. Then find the value of a. This value of a we need to find. So let us see how to do this one. Now you see in this question it is already given that, already in the question it is written here that f of 0 is equal to a. That means 0 is the critical point where we need to find the continuity of the function. So I will write here right hand limit, first of all, limit x tends to 0 plus f of x is equal to limit h tends to 0 f of 0 plus h. Since it is the right hand limit, so from the point 0 I am going h distance forward. That h is a very small quantity, so it is written limit h tends to 0 f of 0 plus h. So what is the right hand function? If you are going 0 plus, that means you are going greater than 0. 0 plus means you are going greater than 0. That means this function is activated. When x is greater than 0, this function is activated. So I will write here in place of x, it will be replaced with 0 plus h upon root under 16 plus again root under 0 plus h. Outside it is given minus 4. So write here minus 4. This when simplified, it will be written in the form of root h upon 16 plus root h minus 4, and limit is always h tends to 0. Limit is always h tends to 0. Now this that we have got is a irrational functions because there is root in the numerator and denominator. So we have to rationalize this thing. So I will write here limit h tends to 0. So we will rationalize this root h by root 16 plus root h minus 4 into root 16 plus root h plus 4 by root 16 plus root h plus 4. So when we are rationalizing this, we will multiply the numerators. It will become limit h tends to 0. It will become limit h tends to 0 root h into whatever is there, root 16 plus root h plus 4 upon this is a minus b, a plus b, so it will be 16 plus root h minus 16. 4 square is 16, that will be written here minus 16. Minus 16 plus 16 cancel, so it is left like this, limit h tends to 0 root h root under 16 plus root h plus 4 upon root h, and this root h cancel. So what is remaining? The remaining is limit h tends to 0 root 16 plus root h plus 4. Now since root h is going to 0, so root h is going to 0, so this is 0. So it will be 4 plus 4. 16's root is 4. So it is 4 plus 4 is equal to 8. So we got that the right hand limit is equal to 8. Right hand limit is equal to 8. Now over here you are seeing that root 16 is there. Now some students will say that, sir, root 16 is equal to minus 4 also. No, it is not like this. If nothing is said, then by default we always consider the root of a positive function to be positive. You have to take it positive only. So root 16 is equal to 4 here. So the right hand limit is equal to 8. Similarly, we have to find the left hand limit now. Let us find the left hand limit. The left hand limit says that limit x tends to 0 minus f of x is equal to limit h tends to 0 f of 0 minus h is equal to limit h tends to 0 f of minus h. Now it will be limit h tends to 0. Whatever the function was given in place of x, we will replace with the minus h. Now what is that function when you are going to the left of 0? When you are going to the left of 0, you are going less than 0, then this function is activated. 1 minus cos 4x by x square. In place of x you will substitute the value minus h. So it will be written here 1 minus cos 4 bracket minus h upon minus h whole square, that is equal to limit h tends to 0 1 minus cos bracket minus 4h by h square. So limit h tends to 0 1 minus cos 4h by h square. Now see, inside the cos function there is minus 4h. Now inside the cos, if negative is there, just remember one thing, that cos and its reciprocal sec, these two functions, when you are giving minus sign inside the function, the cos and the sec, they will absorb the negative sign. So cos of minus x is equal to cos x, and sec of minus x is also equal to sec x. That means cos and sec absorb the negative sign, but if you are giving sign with negative, then it is minus sin x. That means sin minus x is equal to minus sin x, but cos minus x is equal to cos x. In the cos, the negative sign is absorbed, but in the sin, the negative sign is not absorbed, it is put outside. That is why inside here you can see if there was negative sign here inside the cos, but here there is no negative sign because cos absorbs the negative sign. So I got 1 minus cos 4s by h square. Now you can apply the formula 1 minus cos 2x. We know the formula 1 minus cos 2x is equal to 2 sine square x. We know this formula, it is equal to 2 sines. So the same formula will be applied here. It will be 2 sine square 2h by 2h by h square, by h square. 2 sine square 2h by h square, 2 sine square 2h by h square. Now see, inside here it is 2h. I can rewrite this function as, this function can be rewritten as 2 outside sine square. So I will write this one as sine 2h whole square by h square is there now, so I will write this one as 4h square by 4. 4h square by 4. 4h square by 4 can be again simplified, 2 into 4 sine square sine 2h whole square by 2h whole square. Now this can be written as 8. It can be written as 8 sine 2h by 2h whole square. And we know the formula that limit h tends to 0, or you can say limit x tends to 0, sine x by x is equal to 1. Sine x by x is equal to 1. Limit x tends to 0, sine x by x is equal to 1. This is the formula that you have learned in the class 11. So this formula is used here. So what we are getting, 8, we are getting 8 into limit h tends to 0 sine 2h by 2h whole square. This is equal to 1. So the answer is 8. That is the left hand limit. This 8 is the left hand limit. Now we have got the left hand limit, we have got the right hand limit, they both are equal. Left hand limit and right hand limit, they both are equal. That means the function is continuous. So I will write here, therefore limit x tends to 0 plus fx is equal to limit x tends to 0 minus fx is equal to 8. That means, it means that the limit x tends to simply 0, fx is also equal to 8. That means the function is continuous at the point x equal to 0. So at x equal to 0, the function's value was given equal to 8. So a is equal to 8 as per the question. It is a. X equal to 0 is given as a. You can see x equal to 0 is given as a. Now that only here it will become a is equal to 8. This is the final answer. I hope you have understood. It requires a lot of practice in maths. You have to practice. Since you are watching an online demo class, there is no one-to-one communication or one-to-one interaction with the student, because I am just recording my lecture for you to see how you get the output towards your end when you are being taught online through Google Meet. Since I don't have any student joined right now, it's just a recording of my lecture, how I teach online, and the presentation that you will get towards your end on your screen. That is why you may feel like this. But see, this is the entire solution. I have done this one. I have zoomed out the screen so that you can see now. This is the entire solution of that question. Thank you.